What are histograms? Let's discuss what are histograms and where do we use them in our daily lives. Start reading the definition of histogram from IXL. A histogram is a type of graph that uses bars to represent data. You must have listened about a bar graph that normally have something like this. In the data, we have different bars that represent the frequency of different categories. Then what is the difference between bar graph and histogram? A histogram is similar to a bar graph, as I said. However, unlike bar graph, histogram always display numerical data grouped into equal ranges or bins. So what does it mean? I would like to differentiate bar graphs that you know what they are from histogram that you are learning in this video. Okay, here you have one example of a bar graph and an example of histogram. So what do you think, what is the difference? In bar graph we normally represent categorical data where we have categories. For example, we have category of male and category of female, and we are talking about the corona cases cases per 100,000 patients. So there are there are 150 male patients and there are 140 something female patients. So if we have categories, two or more categories in the data, so we have to make a bar graph like this. But when we do not have categories but we have ranges like age group, so we have to make a histogram. If you see at this data, so we do not have categories but we have age groups in the on the x-axis, right? So you can see that this is a bar that is showing from less than 20 patient with age less than 20. This is a bar which includes all the patients that have age from 20 to 30. So this is a range. Whether the person is of 20 years old, 20 years, 5 months old, 21-year-olds, all the patients will be counted in this category. So whenever we have a large possible cases, so we have to convert the cases in different ranges that we call bin, and then we record the data according to those particular ranges, and for that we have to make a histogram like this, right? So you can easily understand where we have categories we make bar graphs, and where we have ranges, do not category but numerical data in small ranges, so we make histogram. And you can easily make the difference. I would like to give you one more example. For example, if you are making a data of country-wise data of corona cases, for example, how many cases are there in Pakistan, how many cases are there in Bangladesh, how many cases are there in India. So we have different categories and we have to make bar graph, right? Bar graph like this. And when we have, for example, we are counting the number of corona cases that for example, how many countries are there who have cases from 1 million to 2 million, how many countries are there who have cases from 50,000 to 1 million. So if we have different ranges like this, so we have to make the histogram, right? So this is the difference between the two. I hope you have understood this. Now let's start practicing this on from IXL. Here we have one more example that will be very relevant for you for a histogram. This is a histogram of dog weights. So if you imagine dog weights, if the dogs are coming to you and if you are measuring their weights, so the weight could be any number, maybe a whole number or a fraction or any large number or a small number. The weight of the dog could vary very largely. So if we give different bars for each particular kg, for example 5 kg bar, 6 kg bar, so there will be infinite bars, so we cannot do this. So what we have to do, we have to make ranges. For example, we will count all the dogs with weight from 0 kg to 29 kg in this bar, all the dogs with weight 30 kg to 59 kg in this bar. So in this way we have made different ranges, and now we can easily count. And here we have example that there are 6 dogs who had weight between 30 and 59 kg. Maybe one of them would have weight of 40 kg, maybe 45.5 kg. So all of those dogs will be counted in this category, right? So we have make ranges which normally called as bins for histogram. Okay, so now let's start practicing on IXL. Okay, this is the first histogram which is given to us. This is the number of magazine and this is the number of pages. Like there are 10 magazines who have number of pages between 1 and 20. Some of them will have 10 pages, some of them will have 12 pages, some of them may have 14 pages. All of those will be counted in this single bar. So whenever we have very large data, very numerical data with fractions or maybe with whole numbers, so we to make it a very precise data or precise graph, we have to convert that data in different ranges or bins. So now what they are asking, which range of pieces is the most common? So most common means the range which has the larger number of magazines in it. So we have to look, most means whenever you see the most, that means we have to look for the bar with the longest height. So this is the bar which is the longest, which has the longest height. So that means there the most number of magazines are in from 81 to 100 pages, right? So this is the right answer, 81 to 100 pages. Okay, the next question, how many amusement parks have between 15 and 19 roller coaster? Right, so there are a number of amusement parks and there are a number of roller coaster, right? So there are 35 parks where you will find 0 to 4 roller coaster, maybe 1 roller coaster or 2 roller coaster or 4 roller coaster. All of those parks will be counted in this bar, right? Similarly, all the parks with roller coasters 25 to 39 will be counted in this bar. So now what they are asking, how many amusement park have between 15 to 19 roller coaster? So they are asking for 15 to 19, and we can look at this histogram and we can say that this bar is saying 15. That means there are 15 amusement park who has between 15 to 19 roller coasters. That's great. The next, how many students took the quiz? So what they are asking, how many students took the quiz? So be careful, they are not asking about any bin or range. They are asking the number of students who took quiz. So we have to count all the numbers. That means we have to count all the bars we have. So let's do it together. We have 6 plus 5 equals 11, 11 plus 9 equals 20, 20 plus 4 equals 24, and 24 plus 2 equals 26, and 26 plus 8 equals 34. That means there are total 34 students who took the quiz. So whenever they are saying in all and asking for how many total, and they are not giving any particular criteria to count for, so that means they are asking for total participants or total whatever the data is saying. The 34. Great. Okay, are there more shipments that had 6 to 10 boxes or shipment that had 16 to 20 boxes? That means whenever we have are there more means there is a comparison between the two or more, right? So it is comparing there is a comparison between 6 to 10 boxes and 16 to 20 boxes shipment. And they are saying which is more. That means among these two, which has the longer bar. So this is 6 to 10 and the second is 16 to 20. This is, so we have to look for these two bars and we have to pick the longer one because they are talking about more. More means the longer one. So this is the longer one. That means 6 to 8 has more shipments than 16 to 20 boxes. 6 to 8 is the right answer. Great. Okay, in this question we have been given a data. This is a data, and fortunately the data is in ascending order, so it is very easy to work with. and we have been given two different histograms and we have to pick the right one according to this data. So first we have to look for the first bar whether it is same or not. No, the first bar is different. So let's see which histogram is has the right first bar. Okay, so this histogram is saying there are 3 students with score 0 and 19, and this histogram is saying there are only 2 students with score 0 between 0 and 19. So let's see how many students are there in this data who has a score between 0 and 19. So this is 1, this is 2, and this is 3. So there are 3 students who had a score between 0 and 19. These 3 students fall in the category. That means this histogram is right because it is saying that 3, and we have 3 such cases, right? So this is the right answer. Excellent. Again they are saying how many bags of candies are there in all. In all means we have to count all the bars. Okay, in this histogram what they are asking, which range of broken ties per shipment occurred least frequently. Least frequently means the shortest bar, right? So you have to look for the shortest bar. Least mean the very few, the fewer one among the all. So least frequent means the shortest bar in the histogram. So this is the shortest bar we have. That means 50 and 59 is the number of tiles which were broken least frequently. 50 and 59. Okay, in this graph we are again given data, but we have been given a data in different bins. So we have to just compare and we have to look for the right histogram. So the first category is 1 to 5, and there should be 2 number of bags. So in this 1 to 5 there are 6 number of bags. That means this is not the right bar. But in this graph from 1 to 5 we have only 2. The height of the bar is 2. That means this is the right histogram. Okay, I think we have discussed all the cases that you may encounter in this data. Now you can easily go on IXL. The code of the skill is CBF and the name of the skill is Interpret Histogram. Go on IXL and practice this. In the next video we will discuss how do we plot and how do we graph histogram. If you want to watch that video as well, please click this link in front of you.